Hello everyone, welcome to Chip Confessions. In our design verification course, this is the 7th session and till now we have successfully completed 6 number of sessions. In the previous session, we were discussing about the data types in Verilog and we completed two major types of data types. That is, initially we introduced what is data type and then we learnt about the net data type, which is like wire data type, and then we learnt about the variable kind of data type, which is reg data type. So in this session we will be learning about the rest of the data types, that is other data types. So we shall see other data types in this session. What are these other data types, or which are the data types we have still left to study with? That is integer data type, and then we have real data type, then time data type, then real time. So we have in other data types, we have integer data type, real data type, time data type and real time data type. We shall see them one by one. What is integer data type? Integer data type represents any number which can be of at maximum 32 bit. Means integer value represents any number which can be positive or negative. So integer is a 32 bit value which can take any number from 2 to the power of minus 2 to the power of 31 to 2 to the power of 31 minus 1 including 0. So integer is a general purpose data type which is of 32 bits and it can take any value ranging from minus 2 to the power of 31 to 2 to the power of 31 minus 1 including 0. This integer is like sometimes synthesizable and sometimes not, depending on the implementation. Like depending on how we are using this integer in our design, this is synthesizable or not synthesizable, we can decide. So what is synthesizable? If I say synthesizable, synthesizable means anything that can be converted to a gate or circuit, means which can be converted to a hardware representation, is called as synthesizable design or synthesizable type. Means whenever we are using some values, means any data type or any loop or any task or any function, whenever we are using them, if that is able to convert itself into a gate or a circuit or a hardware representation after the simulation, it is called as synthesizable construct in Verilog. What is non-synthesizable or simulation construct? Simulation construct means it is only for the purpose of simulation. If we say time, we cannot convert time into a hardware. We cannot convert real time into a hardware, but we can convert integer based on its application. That is what synthesizable and non-synthesizable mean. Synthesizable means we can convert it to a gate or a circuit or hardware representation, whereas non-synthesizable means it is purely for simulation, especially for verification or test bench purposes, and we cannot convert it into any hardware circuit. So coming back to this data types, so we have got to know what is integer data type. Integer data type is a general purpose data type which is by default 32 bit size, and then the value it can take is ranging from minus 2 to the power of 31 to plus 2 to the power of 31 minus 1 including 0. This 31 minus 1 is like this. This is plus to the power of 31 minus 1. So minus 2 to the power of 31 to plus 2 to the power of 31 minus 1 including 0. This is how the integer value is. Now we shall see what is real data type. Real is nothing but, we can say, an approximation to a number. What does approximation to a number means? This real is a kind of data type which represents a number which can never be complete. How we can say that? If I say 1.2, it can never be 1.2. It is like 1.2000000, somewhere it is 1. Like that it is. Means real data type is a data type which represents a number which is not a whole number, but it is a approximation to a number. Means it is a fractional number. That is called as real data type. It is equivalent to float data type in C or C++ also. So real is a data type which represents a number which is not a whole number but approximation to a number which can take fractional values. By default, this real data type has 64 bits. Integer has 32-bit value, whereas real has 64 bits default size. Next we have time. Time represents the simulation time or the actual time. Means whenever we are running a simulation, if we want to know what is the time at this time, if what is happening like that, then we will take this time, and if we print that value, it will print corresponding to the time scale we have taken. If we have taken nanoseconds, it will print in nanoseconds. If we have taken picoseconds, it will print in picoseconds. Like that it is. So time is nothing but it represents the simulation time. And real time is nothing but it is also represent the simulation time, but whenever you are adding a precision, this real time will help. Means if we have an approximation of a time like 1.34 nanoseconds, like that it is, this time will not give that exact value. So this at that time we will use this real time which can give us the approximation or the fractional simulation time. And real time is also 64 bits only, and time is also 64 bit, and both are unsigned. Unsigned means they can only take positive number. There is nothing like negative time. It is only a positive or unsigned or positive number. By default the size is 64 bits. Now we will see in simulation, means by simulating or by running the code, what are the default values and what are the default sizes of these data types. For that I have written a code already, and if you see here, I'll just explain the code. Means I didn't do live coding because anyhow I have not introduced you to coding as of now. So I have just written this code, and when we are into the coding, at that time we can write the code in live class itself or live session itself. So now I have taken a module. The name of the module is main, and then I have declared reg. The name of the variable reg is r, and then is the wire, and I have taken it as w. Then integer I have taken it as I. Then real I have taken it as f. Time as t, and real time as rt. I have declared all the possible data types here with the variable names corresponding to each of the data types. Now what I am doing is I am taking an initial block to display anything or to initialize any variable to any value. You need initial block. Without this initial block you can't display or you can't initialize any variable. Of course we can use always block, but still any of the procedural block it is useful, and we are using initial block because we need not to run this forever till the end of the simulation. If we run this one time, that is enough. That's why we are taking initial block. We will be seeing about this initial block, that is procedural kind of blocks, in our further coming sessions, so don't worry about this. Now you just concentrate on the types I have declared here, that is reg, wire, integer, real, time and real time, and I am displaying these things, that is I am displaying the default values here. That is, I have not initialized or I have not assigned these variables with any kind of values, so that we can see if we do not initialize any variable, what kind of values they can hold. That we will see. And then we will be seeing default size also. What is the default size? Means we will be seeing what is the number of bits by default these variables or these data types can hold. For that I am using a system function, that is $bits, which gives the size of the data type in number of bits. So we shall run the code and see how this works. So we have run the code, and default values we will be seeing. For reg, it is default value is x or unknown. For wire, it is z or high impedance. For integer, the default value is x, and for real it is 0.000, as it is an approximation. 0 can never be equivalent to 0, as I told. 0 is always 0.00000 only. And then we have time, the default value is x for it, and then real time we have 0.0000. Then we have default sizes, and in default size we have, for reg it is 1 bit, means it is showing in bits actually, $bits we are using, and it is showing in bits. And for wire also it is 1 bit. For integer it is 32 bits, and for time it is 64 bits. So we can see a catch here. What is that? We are seeing real, it is showing as 1, and real time it is showing as 1. Why for real types it is showing as 1? Because in Verilog this real kind of data types are abstract, so it is not showing any proper default size for it. For that we need EDA Playground, because it takes system Verilog by default. In Verilog, real or real time or any data type based on real is an abstract data type, so that size is not defined clearly. So what we have to do is we have to go for EDA Playground, and we shall run the code now and we will see. Here I have taken real as R, and real time RT, and $bits only I am using, and then for this also RT also $bits only, and we will be seeing the default sizes. So we can see for real it is 64 bits, and real time also it is 64 bits. So in this video we saw what are these other data types, and we just explained them, that is integer data type, real, time and real time, and we even ran the code to see the default values and default size of these data types. And then in EDA Playground we ran for the real data types, as the normal Verilog compiler will not show, because real or real time or any data type based on real is considered as a abstract data type. So we will be ending the session now. This is what for this session, and from the next session we will start with the procedural blocks or the Verilog, basic Verilog constructs. Thank you so much. Thank you for being with me, and please like, share this video and subscribe to my channel for further sessions or any update regarding any further sessions. Thank you so much. Keep learning, keep coding. Thank you.